3 years, 3 cities for an experience like you've never had before. You want it all. Going to a top business school, learning about AI and data,
Okay, everyone. Good afternoon. I'm Chong Wei San. So suppose you know me already. And today we feel very pleasure to invite Professor Kariana Baramu. If my pronunciation is wrong, please let me know. So Professor Kariana is our visiting scholar, and we are very honored to invite him to our department from this year until to this year. Suppose will be maybe at the end of the August or September. So if you are interested in his topic, maybe you can try to email him, and suppose he can give you he can share you some information and some experience about the research, because he's excellent research. Okay, so before his speech, I would like to give a first introduction to Professor Kariana, because nowadays he just join our meeting every week, and sorry about it, it's too many things. Okay, okay, he just graduated from the National Nanyang Technology University from Singapore at 2006. 2006. And then after a couple research paper and visiting scholar in different countries, not only the Singapore but also the France and also the UK, he just joined this university and Kim Kok National University. This university is located at Korea. So you know that suppose now his nationality is Korea, right? And because we do have the common friend, is the former dean of his university. So 1 year ago, Professor Kariana had the plan to sabbatical. So his friend, Professor Han, just succeeded him to our university. Otherwise, we cannot have such chance to invite him to join our department. So it's very difficult to have him to be our visiting scholar. And also, we do get the support from our government. It's very important thing, because as you can see that if you want to invite the foreigner professor to our university, you should have some support. Otherwise, it just look like just maybe stay for maybe 1 month. But with the support from the government, we can invite Professor Kariana to our department, our university for 1 year. But unfortunately, he will back to the Korea at the end of August. So it's very, for me, it's good friend, and because every month, probably every month or 2 months, we do have some dinner, and then he share me a lot of how to say that, some opinions from different countries, because nowadays we are talking about the global view. We should have some opinions, and also we should have some information from different countries. But how to do that? It's not about your conversation. It's not about your grammar, and also the other thing. It's about do you have any friend in different countries? Because if you have a friend from different countries, you can know how they think, and how their opinion, and how their viewpoint. And then maybe after you graduate from our university, maybe if you want to go to the Korea, maybe you can send the email to Professor Kariana. And as I know, nowadays you do have maybe 5 or 7 PhD people. So you can imagine that if you are the professor at Korea, if you have such such a number of the PhD students, you should have a lot of projects. So I just realized that this project is more than $1 million. Am I right? Yes, so it's huge money if you compare with the Taiwan government and the provide. think about it, 1 million USD dollars, now 1 million pound dollars. Okay, so this is my introduction, but I'm not sure it's okay or not. So let's welcome to Corporate Calendar.
Good afternoon, everyone. I hope you had a good meal. Any reason? Is my voice clear? Okay. So, as I would like to thank Professor Sai for a warm introduction. Okay, so my background, I'm originally from India, and then I left India almost 25 years ago. More than 20 years ago. So I've been overseas for a long time. I spent almost 10 years in Singapore and 15 years in Korea. Okay, so that's the background. And today's talk, we are going through AI-driven shared control architectures for intelligent systems. So here there are many keywords. First thing, attractive AI. So a lot of students are also nervous as well as interested in AI technologies, right? Are you really nervous about AI? Are you nervous? No, you should be. Because the technology is now replacing a lot of traditional workforce in industries, right? So the other thing, okay, we'll talk about that later. Next, we have shared control. So shared control is essentially a interface for human-machine interaction, human-machine interface, or human-machine collaboration, or human-machine combined work. Okay, you should really understand how can we interact with a autonomous agent, and where the autonomous agent understand human and human can understand autonomous agent, right? We are not completely talking about autonomous agents, independent autonomous agents. We are looking at collaborative systems where human and machine together accomplish a task, right? So that is very important in future. Once we have the complete autonomous systems, we don't want to replace every human. We want to leverage the advantages of human brain, human experience, human knowledge together with the autonomous agent, right? So that is the next phase after we develop generative or general AI. We will be looking more into collaborative and cooperative intelligence as well. We can call it mutual intelligence as well. So that's the future. So in that aspect, we'll be actually looking at how can we use these interfaces for vehicles. Now I don't say autonomous vehicles here, right? I'm saying as intelligent vehicles because autonomous vehicles are completely independent from human input or human action, right? You talk about a full-scale driving, for example, Tesla. You don't need human input, right? It can be a fully autonomous vehicle that can freely navigate under any scenario. That's not actually true. There is a lot of other problems documented with autonomous cars as well. But till now, we can replace an autonomous agent on the road to 90% of the scenarios or 95% of the scenarios. There might be scenarios where human might work better, perform better, right? So we want to leverage both human and machine together, right? So that's the main talk. So main talk will be how do we bridge human and autonomous system? So today's talk will not go too much deep because many students come from different background. I'm going to introduce general concepts. At the end of the presentation, I'm going to share with you the current research which we are working in our lab in Korea and what directions our future research is going on. So coming here, I'm currently a professor with School of Electronics, Kinkuk National University. If you want to know more about me, you can visit my website there. Next, this is South Korea, right? You know, you can see Taiwan. We are somewhere here. Right? So exactly, if you are looking at Korea, I am also located in south of South Korea. Okay, that's North Korea and where the current human machine interaction, right? So currently, human machine interaction is what's the major mode for current human machine interaction? How do you interact with a machine right now? You are not interacting. You are interacting, right? ChatGPT, Grok, DeepSeek. You are interacting with already autonomous agents, right? How do you interact? Just type or visual image, right? You can. How many of you played with Sora? Sora, no? So video generator from ChatGPT. You know, it's fun. You should try. Okay, image and video generation as well from prompt. Okay, so there is the medium of interaction for human with autonomous agent is currently with the visual gestures. We can have other interfaces, but mainly with keyboard, right? So keyboard or voice prompt, you can also interact with ChatGPT. Now it's also allowing image prompts as well. So we can use several. So in future, we want to have non-verbal mode of communication. So it can be different interface, touch interfaces or something. So we are looking at what are the possible interaction we can make and how it's going to make a huge difference in future. So that's part of human machine interactions, like a basic introduction about current autonomous vehicles. And then in the third part, we'll go through the shared control for intelligent vehicles. Basic introduction. Then last two parts are two works which we are currently doing. Okay. So I'm going to briefly share about that, and this is the outline of the current presentation. So now very basic, you know, this everybody knows already, but I'm just giving you very basic information about what is human interaction. So anything that has a interface where a human can talk with machine, it can be a keyboard, mouse, even your touch screen, right, on your mobile phone. So it can be a watch on a Siri assistant where you can use voice gestures. So we have multiple modes of interaction and multiple modes of interfaces. So this is with simple assistants you have, chatbots you have currently. But think about future. What can we have in the future? I mean, more interaction, more interfaces. That's what makes more interesting because until now we did not have AI, but once you have the generative AI, everything is going to be different. How are you going to interact in your home? How are you going to interact with your car? Car is going to have one of the huge impact in human life because mobility is so important. So car is not just a car anymore. Car is a device which interacts with you, talks to you, can arrange appointments, can be an intelligent assistant in future. All right. So these interaction levels very important to have an interaction medium. So we are not only talking about just voice and speaker system, auditory, will not give you complete feeling. Am I right? You have a girlfriend or a boyfriend, you know, you have face-to-face interaction. How about you only have phone call interaction? You can't see the face, emotion, expressions, right? No one likes non-facial interaction. So in future, we might have a multimodal interaction system where you can have a huge HUD display, augmented reality, all these things come into play. So we are looking at, so key technologies that will have a huge impact in your daily is NLP. Obviously, you have ChatGPT and all this one, where natural language processing has been really one of the backbone of our current developments. Now, gesture-based input. This technology is still not matured yet. What is gesture? That means you can interact with gestures, right? Human gestures is also very difficult to classify because we have so many degrees of freedom. You know, I know one of the research groups who are working on the gesture based for rehabilitation. You know, they're working for 20 years. You know what's the most difficult task? opening a door, because opening a door uses all joints and degrees of freedom, where teaching machine is one of the hardest. A simple thing, but a very hard from technological point of view. Those recognitions from which whatever the signals are one of the most challenging tasks. So gesture-based inputs now being used for interfacing, where we can tell machines without verbal instruction, non-verbal, right? With just interaction. I think Google Lens, right? Google is also having a nice one of the technology you're going to have in future. Next is generative AI and image recognition. All these things, one by one, all these blocks, when come together, is going to make a huge difference. Now we have everything in bits and pieces, right? So ChatGPT has certain limitations. You only textual input, textual output, or image input, image output, video input. But beyond that, you don't have much of a accelerative where we can give other modality of information. So that's what, if you're looking at the applications, hand tracking gestures for industrial applications, you can teach the robot how to do certain tasks which are very complex, that actually follows your hand motion. You don't need to lift the weight, the robot lifts the weight, right? So we are going to use a lot of this one in everyday life in future. So object recognition, obviously, we have these technologies in a very good state right now compared to 5 years ago. We have object recognition accuracy is very, very high right now. Even 3D, human task identification systems, just from camera systems are also very. We don't need lidar or 3D cameras. We can just with just RGB, we're able to do much better classification currently. So different types of HMI. So when we are looking at human machine interfaces, when you go into a home, let's say in a future home, what kind of interaction will be quite good? Right? You sit in a sofa and no verbal instructions, and you can turn on your TV just by thinking. Right? Imagine you sit and the aircon turns on because aircon and the TV turns on because you sit in a sofa on a location directly viewing the TV. TV recognizes that you are watching the TV and TV is on. Right? And the aircon system turns on. Everything system will be based on human recognition. Once you have image recognition in the homes and the smart recognition systems, everything can be done. The moment you walk into the kitchen, lights will be turned on. Refrigerator, once you look at the refrigerator screen will display what foods are available, what you should eat, what you should cook. You have so much of information available. So that is what the future home, from health monitoring, everything in the home will be done, right? So all these things you need to have interaction medium with the system. Next, voice user Siri, what we have, and next is augmented reality. This is Meta has been working for a long time, right? How many of you, I think everyone is familiar with VR systems, right? In many of the malls here, you have VR games and all these things. Right? Meta has very good VR right now, but not really close enough to simulate a real world experience. We'll have the technology probably in the next 3 to 5 years. We'll have more realistic. Next, we have touchless control systems in cars, motion sensing consoles. We have a lot of this one, right, for gaming application. But coming to gaming, let me tell you one of the technology Meta has been developing, right? You can play tennis in VR. Force feedback. You know what is force feedback? You have a baseball bat, you hit the ball, you need to get the force to your hand, right? Without hitting, how do you get force feedback? Most challenging technology. We don't have force feedback. Even the last 3 years I attended in Las Vegas, I've been very eager to explore the current force feedback. That is going to be the core technology. If you do something, you feel the force, right? In a VR, I have a VR, someone has a VR, and we go and shake hand, I should feel the handshake, right? Current technologies only give vibration, tactile-based sensing, but in future we need to have this kind of real interaction. Where this is going to be a billion-dollar industry. If you can develop a force feedback, you will be the next billionaire. Right? That's a very important technology as well. Next, We have gesture-based interfaces and next wearable interfaces. Watches, smartwatches are going to be ruling. Almost everyone is using smartwatch, right? Simple. You have very cheaper versions, a fun version, but then you'll have this smartwatch is going to be a mini computer in your hand that can document everything about your life. Right? In future technology, your watch, your mobile phone watch, and everything together with your car can gather data, information about your intentions, about what you want to do, and what is your motive of doing. It can actually identify and do before you even ask it. All right. So that is where it's going to be a huge difference when you have all this interface system into an application. So that is where the future technological aspects. So, when you are a student, you should be really looking at technologies that's going to be in the next 10 years, because that is where you should probably looking for your job. Right? Once you're done, then you will have a successful career. You don't want to join a technology that's going down the road. Very, very important. I'll tell you a small story. Very important. When I joined Singapore in 2000, Seagate, the Seagate hard drive company? The hard drive. The hard drive, Seagate? Seagate hard drive company, US company, hard disk. Yeah, very popular in 2000. It used to have 500 people working, almost 300 are PhD scholars in Singapore office. I don't think they have now. All the manpower who studied their entire life on hard drive became obsolete. Technologies become obsolete at certain point. So it's very important for you to keep updated and also learn new things and challenge yourself into the future. Okay, that's very important. So the most important of emerging trends in HMI is augmented intelligence. So how do we augment human intelligence? That is the future. If you are able to give a way to train experience of one person into another person, that's going to be a huge advantage, right? Skill training. Imagine your friend had a certain experience, a certain skill, and you want to learn it so fast, maybe within 1/10 of a time with for technology. That's going to be possible. We're going to have immersive learning experiences so that an experience that requires 10 hours of training probably can be learned within 30 minutes. Another $1 billion technology in future. Skill training, retraining, right? You want to have faster training for humans. So that's one. And then cognitive offloading, which is already done by ChatGPT. A lot of people don't want to use a basic calculator. And how many of you can really think about basic multiplication or addition if I ask you instantly? No one want, everyone uses a smartphone, right? So we have been already cognitive offloading a lot, and this is one of the most dangerous. You know what is cognitive offloading? You don't want to do any complex task. Just like using Google. Google is the first cognitive offline offloading. Everything you want to search, you don't want to remember. You don't want to use your brain. I ask Google. It's easy, right? So that is where your memory starts degrading. Intelligence goes down the path. A lot of students don't understand. Once you start using all the chat GPTs and all these things, your intelligence is gone. It's important to leverage aspects of ChatGPT together with your intelligence to make it more and more powerful, right? So this is very important. So next we have enhanced communication, personalized experiences, on to products and services. So future you're gonna have huge aspects into the human machine interfaces or into the field of education. Education is going to be one of the more core technologies. And also you're going to have holograms for medical applications, biomedical applications. Imaging is very important because your body or all these diagnoses. Okay, that's the future of AML. And now, next decade, we're going to have AI-driven technologies. Maybe in future you will have the fun with them. Okay, next let me go to autonomous vehicle. So this is an autonomous vehicle. I generated it with Sora on ChatGPT. Okay, this was generated with a text prompt. I told I'm going to do a presentation. I need a title page for my presentation. That's what it generated. Not bad, right? So you have what are the autonomous vehicle? One of the most important is sensory information, right? It has a huge number of sensors from LiDAR system, from GPS systems to onboard, LiDAR to radar systems. Everything you need to have in order to make it work. It's a combination of several technologies which we have developed. Now together we are going to have an interface that can communicate with human. Then we're going to have next generation of technology. So this is phase one of technologies. So that's the simple explanation about what we have in a simple autonomous car nowadays. Okay. Yeah, I think everybody knows that. So the other point is we are talking about autonomous vehicles. I think a lot of companies are investing, companies investing in AV because for certain levels of automation. For example, Google Waymo has been expanding silently to many cities, and there is a almost 80% increase in people opting for driverless cars for taxi. Correct? If you have a driverless car, so comfortable, right, in person, but it's gonna take away a lot of jobs as well. Right? The moment you have the human. That's the problem. So we have a lot of interest in this AV technologies in future. And if you look at the patent applications in AV, right, non-linear increase, right, exponential increase in technology growth in the last 10 years. And vehicle market projections, if you see the market is going at 40% per year, It's been clearly visual in everywhere you're looking at the newer generation of vehicles, electric car with all this stuff. It's also very important to see where the technology is progressing and what your role will be in future. Right? You are doing a master's or something, you should be imagining what you will be doing in the next 5 years. That's very important. So now we have several levels of automation and we are somewhere between 3, 4, but not at 5. Okay, in between 3 and 4. We have a certain level of automation, parking, driver assistant. Although they say full HD, full automation, I don't believe them. Although I work on cars, I never buy an autonomous car. I'm not going to buy it because I know where they fail. Okay, so I still like my old car much better. The more the electronics, the more the sensory system, somewhere it's bound to fail. Mechanical link is more powerful. You have a drive-by-wire systems already. Cars are being more and more. So any problem with the chip or electromagnetic interference or hacking can actually change everything in your programming of your car. So I still love mechanical cars, more safer. Sorry to say that. But somewhere we are between 3 and 4 for most manufacturers and around 4 for even the best available market. We are not at 5 yet. The difference is how much the vehicle is capable on the road independently without human intervention, right? If you are driving on a highway, lane maintenance, you can take your hands off the driving wheel and let the car drive on a highway. That's the most easiest, right? Driving on a highway is easier or driving in NS or SU is easier, right? Highway is more easier because simple lane maintenance, you only need to worry about speed and difference. But if you're working on a local road with too many bikes, very challenging. So a lot of things are really difficult for navigation where machines cannot perform really well. And I'm going to skip this slide, assuming. So if you're looking at a future car, we have two aspects here. Environment perception, okay. The vehicle should be able to completely pursue the environment, what is happening around, what the users are there, any dangers, and also to have also planning. So there are two aspects, perception and planning. This is what human brain does all the time. We pursue the environment, make decisions, right? So planning and decision is natural. So we should have machines that can independently progress in this aspect. So one of the major developments, I am just giving you two cars that are the competitors and also the best technologies we have right now. One is the Google Waymo and the other one is Tesla Cybertruck. I just saw Tesla Cybertruck, I think last week near the Kaohsiung Arena. Okay. So no, I haven't seen many Cybertrucks in Taiwan yet, maybe in Taipei. So it's a major advancement. So the main advantage of having electrical is about efficiency. Electrical motors have very less losses, mechanical efficiency is very less. So one of the major aspects with the cars is about EV or like software-based vehicles, because there will be like almost like a hardware running on software in future. Cars will be. So main advantage is safety, fuel consumption, and all these things comes in play. So the main mode into the future, where this will work into the future, is about how we're going to deploy AI and intelligence to this vehicle, right? Until now, we haven't had any intelligence, right? We don't have any intelligence yet. Most cars are based on algorithms, based on object recognition, speed, and all this one, the calculations are made. There is no AI involved. Although there are certain reinforcement learning based algorithms are involved in the coding level, but mostly they are output. Okay, so that's what we've been doing right now. So in future we'll have more immersive experience. So once you get into the car, you'll have a very good immersive experience in entertainment and infotainment. Now, most important of one of the major aspects of why shared control comes here is about safety. Okay, now we will ask you, people are advertising autonomous cars saying they are safer than human drivers. Number of accidents, number of all these things. Alright? So the point of selling an autonomous car or something is about safety. Alright? Now, first thing, I just ask you a simple question. Suppose there are two autonomous cars collide. How do you make prediction on who is wrong and who pays the insurance? There is no driver involved, right? If there is no driver, our systems are very difficult. We don't have legislation systems yet. I don't think any Asian countries have any regulation because we haven't thought about that, but in future. So not only that, we have one of the most important is human trust. A lot of discussion about their autonomous vehicles. I think in the last few years about human trust. Whenever there is an accident, a lot of people don't want to buy. If there are a few accidents, number of sales of Tesla cars slightly dropped. And when they say their technology is safer, many people buy it. So the fundamental aspect is trust in autonomous car. And if you look at the number of accidents, they're not less. Even the Google Waymo and Uber and Tesla had many number of accidents. So simple example. So if you look at this one, there are several accidents involved with autonomous cars as well. One of the big problem is when you have this one, this Uber self-driving car killed a pedestrian. Right? So technology is supposed to be safer. So how come that the technology fails sometimes? So this is one of the major aspects. So trust is another major factor. So not only accident, if you are looking at why we need shared control is the next level of technologies where we are going to use autonomous vehicles and involve human, right? Involve human. Now, if you are looking at one of the fascinating technologies we have is the modern airplane, right? Boeing, the Boeing airplanes, they're one of the complex control systems ever designed, with so many sensors and safety records. So even then, you see, taxi mode is there in the airplane where pilots just relax and watch movies, where most of the pilots concentrate on landing and takeoff. Most crucial aspects. Most difficult is landing. Takeoff is also easy. Where most accidents happen during landing. Right? So you are working against gravity. So the other problem is there is two controls here. The aircraft has total autonomous control. That is where the flight flies completely on itself, where the pilot does almost nothing. Right? So, so we have this kind of switching controller. So certain phases, the pilot takes control, and most of the time, aircraft takes control. So coming to car, you don't have the division. You know, either you have an autonomous car or a human driving car. You can't have a shared control. You can't say, I'm driving on the car, take care of some such of systems for me. But it only can give advisory, but it cannot be done as a supervisory. So we are looking at technologies where we can use both human and machine together. So what are the several ways we have is we have one is supervisory control where the automation is in control while driver monitors the system and adapts. So this is what every technology recommends right now. Okay, you sit in a car, watch the TV, and you don't do it. That's the toughest job. Because if you do nothing, your brain cannot concentrate, right? You will either go to sleep or watch something, get deviated. When something happens, you can't react. So that's the most. This is one of difficulty. If you are going to sit in a car watching it like this, actually, it's not going to help. So that's one. Allocation control. The machine is charged of one subset while the driver is responsible for other. Okay, you focus on driving, I'm going to give all the information and help. If someone is going to crash, I'll help. If someone is going to do something, or lane change assist, all these two features. So that is where many people are liking this kind of feature subset where like parking, auto parking, lane assist, like lane departure warnings, all these things are out there. So this is allocation control is fine, but there is fixed. You can't trade off. You can't say you drive the car for me for some time and I'm going to relax. That cannot happen. So that's one is about allocation control. And then traded control. We have traded control is automation with traded control is something like switching only. Okay, you control, you take control, or I take control. That's it. Okay, if the vehicle sensors have a problem, it cannot monitor the environment. You tell, okay, I can't just drive yourself, right? Either human driver or machine. And then guided control is where driver has ultimate authority, machine will assist the driver. So when you're looking at guided control, it only guides you. All decisions, all actions are done by you. This is where most of the cars or technologies we have currently fall into this category. You have all the information. Okay, now let me come back to the basic of shade control. This slide is very important. If you see here, machine operator, human operator, you have a switch, right? Either you have a machine that is autonomous or a human. You have a switch, like Tesla. You can either switch between autonomous mode or in this mode, 100% controlled by the vehicle. In the human operator mode, you'll be driving, right? This is what we call mission-centered state control. I can't say it's human-centered because mission decides where to share the authority. Method two, haptic control. You know, haptic control is just a summation of both the users. So what happens in a haptic control is similar to flying Boeing 777. You know, Boeing 777 has haptic shared control between two pilots. Two pilots are doing opposite, it averages both the inputs and actually does that. Okay, that's kind of safety control. But if you are using for a car, if I'm driving a steering, right? Machine is driving and I am driving. Together we are applying force. I'm trying to make a turn, machine is already trying to make the turn. So you're going to feel the force of the vehicle. So you're going to have two forces coming, one from the machine, one from the user. So how going to solve this kind of aspect? Okay, how much aspect of control lies with me, how much aspect of control lies with the machine, right? This is state control. We're going to discuss about that. So one of the major disadvantages is this is impossible for human machine mutual learning and adaptation, right? This is a boundary here. You can't learn the machine cannot be learned because everything is fixed here, right? You can't really understand what the machine. So either you like the Tesla car or you don't like its control, buy another car. No choice. If there is no adaptation, it doesn't understand your driving skill, it doesn't understand right? So it doesn't adapt to your style. Next, the major problem with this kind of controls is there is a conflict. So what is a conflict? If you're driving, you think driving on this lane is better, but the car decides to go in with a wheel not like that. It always does this thing. I don't like this thing. Right? Conflicts are common when you have two agents working. Even when you have two friends, there will be conflict, right? So what to drink, coffee, tea, you have an issue. So conflicts are very common when you have multiple agents. So one of the most challenging in future is how do we resolve human machine conflicts? Okay. So now the major aspects of future technology is no scope for human intent. What is human intent? I want to do in a certain way. I want machine to understand my intent. I want machine to understand that I want to do and act upon. I want to drive in this way. I want the car to understand my driving style, my driving philosophy or driving way and actually drive accordingly. That means every car will be customized to the user. You drive your car for 6 months, the car learns about you. It accelerates, it decelerates exactly like you and behaves like you, right? This is the next level where users will really like about the car because it mimics the user style of driving, right? I'm not talking about safety. I'm talking about human adaptiveness and where human and machine can trust each other. So that is what the future technology. Okay. Trade control application. If you're looking at a car, very simple. You have an automation agent, a human driver, both provide controlling, right? Both provide. That means in a shared control, you are always on the steering wheel, right? Now, if you are always on the steering wheel, why shared control? Why do we need shared control if you are always on the steering? Anyone? Safety? In a in a shared control, what the machine does is to do certain tasks. Suppose, okay, what the point of the shared control is to leverage human experience, human knowledge together with the machine. There might be a scenario where you can perceive there is a threat or there is something problem with the road or this one, you can act accordingly. Where the machine cannot, because if a Tesla is running at 100 miles per hour, okay, it can only look for the next 100 to 150 meters. It does not look beyond that. If you are traveling at 100 miles per hour, that means close to 160 kilometers per hour, the reaction time is very less. The physics, the braking, you can't just brake the car at 160 instantly, can you? No technology can bring your car to rest unless you collide with some, right? So the point is there is a limitation because of the friction, the braking, everything. So if you have a fair knowledge that there is something problem ahead, human can actually also work together. So there are scenarios like you're driving and you are feeling sleepy. The mission observes that your steering force applying is very low. It takes so. That means the allocation of control is always changing dynamic. Suppose I'm in a very good mood, I'm driving everything, the car detects that I am doing high level of acceleration, it gives almost 90% control to me. If you are feeling sleepy or you are doing something, car takes over 90%. It's mutual, right? It's based on your style and then something, the adaptation happens all the time. The thing, your machine understands your intent, understands your behavior, and adapts accordingly. So we need an intelligent, smart car that can actually track human. So that's why in future we'll be relying on biomedical data from your smartwatch, visual sensing in the car. All this information will be fed into the system to do this one. This is about self-control autonomous and also for unmanned vehicles, been doing a lot, right? A lot of things have been done already. And robotics is another one, and also remote surgical application. There are many companies working on remote. That means a surgeon can actually sit in his office, just like getting a Zoom car. He can do even complex surgeries. Why complex surgeries? Because the human precision is not really good. Okay, I worked on microsurgical robot for like 10 years, a handheld robot system for microsurgery. Human hand has vibration in 50 micrometer, 50 micrometer, 10 power minus 6. Very small, you can't see. I can see my hand is steady. You keep it in a microscope, you can see your hand is moving. Sometimes your, vein in your eye is 30 micrometers. If your hand shaking is 50 micrometers, can you do something at 20 micrometers? Impossible. So we need precision. Robots are no problem. They're super steady. So if you have a controller and you are doing here, it filters out all this vibration and only detects the main task and does the job perfectly. So we are leveraging machine precision with human intelligence. Together, we can achieve a goal which human cannot do, right? That is a good example of human machine interface and shared control. That means advantages of both the technologies, human technology, memory, experience. We do everything from our experience. So we can use all these skills to actually augment precision. Now coming to shared control of vehicles, we combine human expertise with automation control capabilities for safer, more reliable driving experience. What we are trying to do here is you have automation and you have a driver, right? Driver wants to go this way, automation wants to go this way, and the resultant goes this way. It depends on the gates, right? How much allocation for the human driver, how much allocation for the shared control. So that is how in theory it works. So this is a dynamic system where the control authority shifts seamlessly between human and machine. So that means the human and machine sharing the same load, but it changes all the time. If it's a too complex that requires speed and precision, machine takes over. But if it's an experience-based task where human knowledge is required, machine gives more control to you. So that means leveraging both human and machine advantages to give ultimate safety and reliability. So benefits of shared control mitigates risk by leveraging human judgment in uncertain situations, enhances user experience. First. Most important is imagine a car that actually mimics you, behaves like you, and gives an experience that you will like. Will you trust it or not? Right? So the point is, if you can adapt to the past, car can adapt to you, both together can do a much better job. So that's the main aspect of state control. So the main aim is to create a collaborative relationship between humans and AI in driving. So the focus on enhancing driver performance and reducing the risk. Okay. So those are the main aspects. Can you skipping this slide? So I'm going to the main aspect of state control and another diagram made with ChatGPT. Right? Earlier you want to do this one, you have to spend almost an hour, 2 hours, and the quality is also not good, right? So now you can use ChatGPT, give the description and tell how it makes multiple iterations, takes less than 2-3 minutes, right? So that's one advantage of using machine. But you can't just say imagine something, but in future probably our imagination and intent can all be taken into account. You see this one? The slide is showing. Okay. So human intent is in this direction, but machine is going in this direction. That's when the user gets angry or disappointed, right? So it depends on experience. Sometimes you feel this action is more safer, but machine does based on a simple differential engine. It takes multiple scenarios and see which is more safer depending on your algorithm relative weight selection of how what is safety. Your algorithm will decide. So the shared control is more about getting human into the loop of authority and control. So this is one of the projects which been doing, which we call behavior intelligence system. Okay, this I'm a co-PI in this one. It's not a single project with other professors. So what we do, oh sorry, I didn't change the Korean word. Okay. So last one is control. Okay. This one is judgment, and this one is cognition. Okay. So cognition, judgment, and control. So so this is what we call cognition. Human cognition is very important. If you want to have a smarter interface, we should understand human. How can machine understand human? From sensing, right? So maybe a brain sensor, you can use eye tracker, tactile sensor. If you are in a, you're sitting, right? Your feet can monitor. Your hands, if you're holding your steering wheel, can have tactile sensing where you can also measure the force you're applying. You can do multiple things. Your watch today has so much real-time data you can actually associate. So we can monitor human, and also you can have vision-based that observes the driver, gauge detection. Okay, all these things sensors, we can actually make cognition based on biosignal. So we can use this information to give behavior decision based on machine learning. That means we want the machine to imitate the human, right? Behavior limitation. So bringing in that one, we have behavior generator or behavior coordinator based state control, and we can bring it to learning based control for many applications. This is many applications where I'm working on the car. One of the professor was working on a robot where he wants a robot to see a YouTube video and learn, right? So robots should watch a video and understand the joint motion, how it's in. So this is more about limitation-based control. This idea is to teach robot how to do certain tasks of writing or doing something from the joint level. So there's something that very challenging. Sometimes we feel that certain tasks are so simple. Imagine I want a robot to write on a whiteboard. That's more challenging, because robot does not understand how much pressure to apply. Because you have a chalk, apply too much force, it breaks. You apply too much less, it does not rise. So teaching a machine to apply certain pressures is also very, very challenging. Simple tasks can be very challenging. Now, this is what we have been working on, what we call game theory based shape control. I'm not sure you're familiar with game theory. Game theory is about agents playing the game where you have cooperative, non-cooperative, or multiple scenarios. Okay, it's a theory. So the what aspects we are hearing is we have human and machine working on a shared control. We need to bring out what is the control authority shifting for human and machine learning. So we want to use game theory, but if you use only a game theory, you can always you can have cooperative behavior or non-cooperative behavior. So if you have non-cooperative behavior, we can't achieve Nash equilibrium. That means the system may bound to fail. So what we are trying to do here is we can get human intention from the human sensory information, so that once you take this information into this one, you can teach machine to avoid conflicts. So machine understands the human intent and behaves such that if you can change the non-cooperative behavior to cooperative behavior. You can change the non-cooperative behavior to cooperative behavior, human intent. So if you are able to understand human intent, understand what human want, intent, that means action before he actually does something, so that we can modify the whole architecture. So we can actually bring in human into the loop, human thought process into the loop, so that much better performance. In another way, in another diagram, we show how we do that. We get BIOS signals, and also we have multimodal network. We can get the gauge and all this one, plain a GCN, and get the intention. Intention is not complex. I want to drink a coffee. No. If you are in a road, right, lane changing. Intentions can come from multiple. If you want to lane change, you'll be observing the mirror, right? Reverse mirror, and you will be observing, and maybe your hand force will be about the other. This forms before you implement task. These minute tasks we can identify from the raw data and tell the machine that the human is intended to move to the left lane, not to the right lane. So machine which is planning on the right lane is to the left. Why left lane? Because you perceive that this is a truck, it's dangerous to go on that direction. Maybe the driver will change in future the other lane and I don't trust him. So you want to move to the left lane. This is human experience. Mission cannot think in that way. So we are teaching so that we can give human intention into the loop so that we can bring much better performance. So this is the whole aspect of our human intent centered shared control. So into the shared control, how do I bring human intent? So we have several intention classes from EMG, steering wheel, and vehicle states, and we can actually identify certain intention classes in simple way. So generally, when you have paths, you have several paths to go, right? So the vehicle makes several paths. This path means maybe simple lane changes or simple not for the whole big global path. I'm talking about local decisions. So you have mission plot planner, and then once you have human intention, if the conflict is identified, that means if there is a aspect where human is actually eyeing one path and mission is eyeing another path, and if there is conflict identified, so that the machine can modify its behavior so that there is no conflict, right? And then we have an object mechanism where we use reinforcement learning based. This one is the shared control, okay? So R-based rate allocation based on vehicles and control how much is lateral movement of the car, whether the stability is weak. So if there is a stability issue because of the human driver, then we try to give more allocation to the machine to correct it. So we give control to the human, but at the same time, when certain parameters are out of the limit, machine steps in, right? So that's one major aspect of this. This is how the conflict in certain way. So when you have different target paths, right? Human is thinking in this path, machine is providing in this one. Because of the intent, human intent going in, we can update the machine path to avoid conflict. So this is a very simple aspect for lane changes or something in a car where human intent can be very powerful application. So in terms of a conflict, we are taken machine path, very simple here. I think I am just going to skip this one. So this is game theory based reinforcement learning framework. So we use game theory plus reinforcement learning together to give a algorithm, or we can say kind of learning based system where we can give allocation authority for human and machine. I don't know how much time do I have. Okay. So in that way, maybe I'll show you some of representation. Okay, we just do one last aspect to give you what technology being here. Okay, this looks very big, but don't worry. So what we are trying to do here, what we have done already, is to take thousands of driving profiles, driver driving behaviors like lateral acceleration, longitudinal acceleration from German database where you have thousands of drivers driving various cars. So we take all this data and train our reinforcement learning to teach machine to imitate human style. Okay. So we use reinforcement learning and inverse reinforcement learning to generate reward function automatically, and then so that we can mimic the style of the human. So this is work that actually teaches the vehicle to imitate human. So the machine can imitate 100% of that. So in this way, we're gonna use this one to teach so that the vehicle can behave like human. That is, the machine part also behaves like human. So suppose you are driving the car and machine behaves like you, right? That's an equilibrium. That means that is what we are trying to do. So that means we are training based on the driving profile of the driver. to teach the car on how to accelerate, how to, that means you are a sports car driver, you want to drive very fast, your acceleration is high and low, it follows you. Right? So within the limits of state, within the limits of state. So I think that's the main aspect that I think is doing the plan. I think I can skip certain parts. Finally. And last one, there was several solutions of this question if you are interested in any of these technologies. And we are also working on smart, force feedback systems to give human feedback. Okay, that's one of the also. And this is my lab, and this is my lab address. If you are interested in future, you can contact me for PhD. And finally, time for question and answer. Thank you.
Okay, thank you very much for the study, for your insight speech. Okay, so before I do have a few questions, but before my question, any questions from the students?
I have a question on shared control system. As we know, there have some human-machine conflicts. So the architecture have some method to reduce the conflicts.
Sorry?
I remember one PowerPoint have two different shared control system. Yes. And is there any method to reduce the conflicts?
Yeah, that's the human intention.
And which one is the most popular in current?
There is no current implementation. Only in R&D and labs we've been doing, because none of the current systems uses human intent. Human intent is so complex, and only in restricted cases. Suppose you're in a car, you are actually looking at certain scenarios, you can predict certain scenarios with 60 to 70% accuracy, not higher than that. Specific lane changes, behavior on user behavior. He's looking at the back mirror, he's trying to shift the, and so if you want to make a lane change, any driver has standard way. First he observes the lane, right? That also the lane is clear and no traffic, and then he looks at the back mirror, so he tries to see whether everything is okay, then out of course application on the left hand, we can detect. So once the human intent, it's like as the time is progressing, once you start looking, algorithm will say 50% probability that he is actually want to change, and then once you start applying right based on the left hand, then the car will detect that with 70% probability your intent is to. It's a probabilistic model. We can't accurately estimate human intent. It's one of the most tough topic. Even you have 100% brain imaging, it's also very difficult.
Just look back, even though the human still cannot understand the other guys. You know how I mean? Because this kind of drawing system is we have the human and the machine. So even though the two parts also both the them are the human, another one still cannot fully understand the mind of another one. Yeah. So any other question?
Thank you, Doctor, for your talk. And I'm interested in talking about the biosignals in the first phase of the cognition. So you talk about how the EEG and the tactile sensors all put into letting the machine know our human intents. But as we know that EEG, you need to put like a lot of signal pads and on the human and tactile sensors as well. How do you realize that in real life? And because in a car, usually we just sit in the car. And how does all these signals turn into like electronic signals and integrated and allowing the machine to know that is our intent?
Good question. So EEG is only for research purpose, initial stage only. So end application will not have EEG. End application will rely on the tactile means we have pressure based on the steering wheel. So you can actually identify the force applied on the steering wheel. And also we have simple EMG based sensors available in the watch as well. In future, we'll have a smartwatch already connected to the car ecosystem. So you can always gather human heart rate, whether emotion level, and is intent. You can filter certain kind of. So if the human is very angry, we don't give control to the car in the user. Okay. If his heart rate is higher, if monitoring, so we can have so much of information about the user. So I know the history of this guy, and then the vision, we can track his eye movement. So a lot of things with 60 to 70% accuracy we can identify. But EEG is only at the initial stage of research to understand this timing cues. We're going to use it as a baseline. And in future, I think once we develop the technology, which may take another 10 years, then we don't see using EEG.
Last question from the student. Any other question? No. Okay. Okay, students, you must understand that this presentation is a good presentation. Why I say that? Because I should ask the question. So from his presentation, I try to find out some questions. But every time when I got the question, after a couple slides, and then the Savasayana slide just answer the question. For example, when you're talking about the instance, and then I think about it, but how to the system distinguish the instance and the instance, and then about how to understand the human's mind, and then he just give us some material to detect the conflict between the machine and the human. So that's why I say it's a good presentation. If you want to make a good presentation, you should follow this style, but also your paper. You know what I mean? Otherwise, your paper is very difficult to read. If you read someone's paper, you can figure out why someone's paper is very smoothly. It's because after a couple of minutes, you can get the answer from the paper or from the presentation. But I just only have one question. Sorry about that. And how to distinguish the Eastern and Eastern, because it's very important for the insurance. When something happen, I mean the essence. But if you cannot distinguish that, who should pay the money?
Exactly. That's a very difficult area, because if two autonomous vehicles have an accident, it's not a error of judgment or algorithm error. So the blame should be on the manufacturer or the driver. So you can say I'm not driving, I'm just a passenger in the vehicle. The car chooses to. If a human is present, then the scenario is different. But I think US Transport Department is making certain progress on this one, but this legal framework is not yet fully developed. In future, we might have two company robots going to be in a coffee shop. They both fighting. So we don't know how it's going to happen unfold. Unless you have the machines coming to the world, they can be cooperative behavior, non-cooperative behavior, right? Two different robots. You ask him to go and stand in a line, the other one stands there, right? Both try to get the same objective, difficult, right? Only one succeeds. Then what happens? There is a competition, there is a conflict. So how do we resolve? I think the legislative framework should really study. And coming to the autonomous stuff, the one thing is you have too much of data. Every second you have data on how it made the decision. So it's based on assumptions, but I think at the end of the day, what caused the accident is also very difficult to identify. But If we follow all the data, most of the accidents involve this one, they identify because of a sensor failure or hardware issue or momentary blinding of sensor or camera or something, or there is too much fog in the environment, or the camera cannot identify the user was behind the tree and it cannot see, and then suddenly the user came. In that scenario, we can't blame the technology. I think even a human driver would have hit 100%. No, enough, because our reaction time is much more lower than the car. Car can act within 2 milliseconds, but human requires 0.5, almost 500 milliseconds reaction time. By the time you take off your accelerator and press your brake, the light is gone. So it's a very controversial and also it's a very difficult area. I think future, once we have so many agents, even drones flying, 2 drones collapse. We have 2 companies, delivery robots, they collapse. So we're gonna have the framework divided by the government on saying what is the space. If you have one agent, your one agent should not enter that space. Like satellite spaces, you have certain universal regulations about distance and view. In 3D space coordinates that what defines one satellite space and other cannot go into a certain paths defined. So I think in future we're gonna have certain frameworks about and which path we're gonna decide them.
If you like me, after this presentation, I just come up with a lot of idea. For example, I feel that the data fusion is very important thing in such kind of system because you need to integrate a lot of the information from the human intent, like EEC or ECG or something like that. And also, for me, it just looks like the queries because you need to understand the human mind. So you need to collect a lot of information from the human. So the data privacy and security is very important thing in such kind of system. And also, okay, for the other, just look at how to make a good decision for when the human and the machine have some conflict. So I hope you guys come up with a lot of the new research topic, and then it will be good for your research, especially you are the graduate students. So if you do have other questions, maybe you can send the email to Professor Tariana Valamo, and then I suppose he will be very happy to answer you. And yeah, just do that. Okay, so just one small question. How do you mean the fully funded PhD position? You mean you were paid everything?
Yes, I think in Korea we pay like no tuition fee, no fees for the university.